All right, let's dive right into this explainer. Think about human history for a second. For centuries, literally across our entire existence, human progress was defined by the tools we built. We're talking simple things, hammers, pulleys, plows, implements that were designed strictly to just extend our own physical strength. Mastering inert matter, basically figuring out how to manipulate stuff around us, has been the defining characteristic of human evolution. But today we are crossing a profoundly different threshold. We aren't just building better tools anymore. We are literally building machines that can use tools themselves. We're talking about machines that can sprint through forests, navigate chaotic city streets, and even perform delicate micromillimeter surgery. They are learning to perceive their environment, and crucially, they're learning to think. And honestly, very soon, billions of these machines might quietly just step right out of the laboratory and become this invisible yet totally essential part of our everyday lives.
And the contrast between traditional human tools and these autonomous machines, it's a monumental shift in how we interact with technology. Think about a traditional tool. Whether it's a lever, a power drill, or even your high-end modern laptop, they're fundamentally static, right? They sit there. They require constant, active human input and direction. They are literally just waiting for you to hit a keystroke or pull a trigger. Modern autonomous machines, on the other hand, are dynamic agents. They aren't simply programmed to repeat a single rigid motion in some endless loop. They are equipped to constantly perceive the chaotic world around them, learn from highly localized data, and dynamically adapt their physical actions without any human intervention whatsoever. We've shifted from static implements to proactive agents. And what this means is that robots are no longer just confined to, the bolted floors of heavy manufacturing plants. They are rapidly advancing toward becoming our coworkers, our companions, and even our caregivers.
So that brings us to the really central question we're unpacking today. Are we genuinely entering the age of the everyday robot? And why does this transition matter so urgently right now? Well, because if we are, the fundamental fabric of human labor, of global macroeconomics, and literally our daily lives is about to be completely rewritten. But to answer this, and to truly grasp where this robotics technology is actually heading, we first have to step back and understand how it evolved. How exactly did we go from science fiction novelties to the reality we are seeing right now?
The journey is actually pretty wild. It starts way back with ancient automata. These were basically early mechanical curiosities built by Greek engineers that just mimicked life using moving water and weights, kind of like really elaborate toys. Fast forward a bit to the 1800s, and we get the Jacquard loom. This was an early industrial machine that used literal punch cards to automate weaving. That was the true dawn of programmable machines. Then, in the 1920s, the actual word robot was coined. It was in a Czech play about artificial forced labor, which obviously went on to heavily influence sci-fi writers like Isaac Asimov, who completely shaped our cultural expectations. Then came the 1950s, when the Humanoid robot became the first truly programmable industrial robotic arm welding car bodies for General Motors. But here's the catch. For decades after that, progress just hit a massive brick wall. Robots remained isolated, completely blind, and literally caged up in factories. They just couldn't handle the chaos of the real world because computational limits held them back. But then, one major discovery accelerated absolutely everything.
Which brings us to Section 1. The intelligence breakthrough.
Okay, so here is what's absolutely fascinating. The real breakthrough wasn't just physical hardware. It wasn't just building stronger gears or better electric motors. It was a rapid, almost perfect storm convergence of 4 completely distinct technologies, all peaking at the exact same time. First up, foundation AI and large language models. This finally gave robots a brain capable of actual semantic understanding and reasoning. Second, computer vision and LiDAR. This gave them highly perceptive eyes, allowing them to map out complex 3D geometry in real time. Third, edge computing. This is huge. It enabled zero-latency reflexes by processing gigabytes of sensory data locally, right there on the robot itself. Actually, scratch that. It's not just local processing. It's doing it instantly without waiting for a slow cloud server to respond. And finally, advanced batteries. This gave them the untethered, long-lasting power they needed to leave the lab. It's this incredibly specific, completely unprecedented synergy that is finally allowing machines to break out of highly controlled environments and actually interact with the messy, unpredictable, real world.
And honestly, we're already seeing these converging technologies being deployed in some pretty incredible ways, even though every field still faces its own unique bottlenecks. Take global logistics and warehouses. Autonomous mobile robots are actively dynamically routing around humans to sort and ship goods 24/7. Now, the high initial capital cost is still a major limiting factor for smaller businesses, but the big players are all in. In healthcare, it's even wilder. Robotic surgical suites are in there, executing procedures with a level of precision that literally no human hand could ever achieve. The limitation there is mostly just tied to rigorous FDA safety redundancies and, understandably, the need for human oversight. And out in extreme environments, we have autonomous rovers navigating the incredibly unforgiving physics of Mars completely on their own, while drone swarms are assisting in disaster response right back here on Earth. The core capability is undeniably here, but scaling this technology globally? That actually required an entirely unexpected macroeconomic catalyst.
So, let's move to Section 2, the new global economy.
Here is the reality check. The world is currently facing this massive, completely unavoidable demographic collision. On one hand, developed nations are aging, and they're aging fast. This is drastically shifting the ratio of active working-age people to retirees. On the other hand, we are seeing absolutely unprecedented structural labor shortages across the board. Manufacturing, logistics, elder care, you name it. There simply aren't enough young humans entering the physical workforce to sustain our current global production and healthcare needs. It's just a mathematical fact. So these two undeniable demographic realities are forcing the business world to pivot completely. Automation isn't just some clever efficiency play to bump up profit margins anymore. It is an absolute, non-negotiable necessity for economic survival. And that is what's driving this urgent, frantic dependency on semiconductor manufacturing and robotic integration.
And this massive macroeconomic shift perfectly explains the sheer volume of capital that is currently flooding into the sector. I mean, we are tracking tens of billions of dollars in venture capital and strategic AI investment. It is wild. This money is just pouring into humanoid startups that are actively attempting to build universal, bipedal labor forces. At the same time, you've got established industrial manufacturers and major tech giants heavily subsidizing AI compute power and snapping up robotic supply chains. The global business world has collectively realized that whoever solves the general-purpose robot problem first will essentially capture a foundational market. And I mean a market that spans across literally every single physical industry on the face of the planet.
To put that into perspective, just look at the adoption rates worldwide. It is becoming truly exponential. Nations like South Korea, Singapore, and Japan, they are leading the pack right now with absolutely skyrocketing robot density. South Korea, for instance, has already integrated over 1,000 robots for every 10,000 human manufacturing employees. That is huge, and it is no coincidence that these are the exact same countries facing the steepest population declines and the tightest labor markets in the world. The robot economy is quite literally stepping in to fill the demographic void, firmly setting the stage for what will likely be one of the most massive industrial shifts in human history. But, and this is a big but, beneath all these metrics of productivity and these skyrocketing startup valuations, there lies a much deeper, much quieter conversation that we urgently need to have.
Which brings us to Section 3, the hidden human cost.
Unpacking the complex duality of this shift means we have to look way beyond the balance sheets. The opportunities are historically unprecedented, for sure. We're looking at immense efficiency, the potential elimination of hazardous, backbreaking manual labor, and the birth of entirely new industries centered around robotic maintenance and programming. It's an incredible upside. But sitting right alongside those opportunities are massive, massive societal risks. We are genuinely facing widespread job displacement in entirely new sectors. We aren't just talking about assembly lines anymore. We're talking middle management logistics, delivery drivers, and basic caregiving roles. Plus, AI safety takes on a terrifying new dimension when you put it inside a mobile, physical chassis, right? It's no longer just about some computer program generating a biased text response. It's about a 200-pound machine making complex physical choices in heavily populated spaces. Add in the alarming potential for unchecked mass surveillance and the deployment of autonomous military weapons, and the stakes literally could not be higher. Because at the end of the day, things like cost reduction, mechanical reliability, battery life, those are ultimately just engineering problems. Given enough time and capital, the free market will solve those. The true bottlenecks for this entire revolution are societal. How do we secure millions of highly capable autonomous agents against localized cybersecurity threats? How do we protect the intimate, deeply personal data privacy of the homes and the hospitals that these machines will navigate every single day? How do we root out embedded biases in algorithms that are making real-time physical decisions about humans? But above all that, there is the hurdle of human trust. I want you to consider the psychological barrier of trusting a humanoid robot to prepare food for your toddler, or allowing a massive autonomous machine to navigate its way through a crowded crosswalk with your family. Trust is the ultimate regulatory currency here, because without human trust, the greatest technology in the world simply cannot scale.
And that leads us to our final section, Section 4, the future of humanity.
So, grounded in current institutional data and verified research, we can actually map out a distinct trajectory for the coming decades. By 2030, the goal is for humanoid household caregivers and personal robot assistants to make that leap from lab prototypes to commercially viable products, fundamentally altering domestic life and elder care. Looking ahead to 2040, the projections scale up dramatically. We're talking autonomous construction fleets and AI-powered manufacturing hubs literally reshaping the physical architecture of our smart cities. And by 2050, the integration deepens into profound human-robot collaboration. We are looking at the widespread use of brain-computer interfaces where humans are seamlessly directing robotic avatars, and the deployment of highly advanced general-purpose robotics to go out and construct lunar bases and space colonies long before human crews ever even arrive. We are methodically, step by step, walking toward a fundamentally different world.
You know, every great technological era redefines the human experience. For thousands of years, humans built machines to extend their physical strength. Then, we built computers to extend our memory and our mathematical capability. Today, we are building machines that may actually extend our intelligence and our creativity. And, perhaps most profoundly, as these autonomous systems start assisting in areas like highly attentive healthcare, specialized education, and really dangerous disaster relief, they might even extend our capacity for compassion. Think about it. They could free up human beings to focus on deep interpersonal connection while the machines handle the rote logistics of care. This isn't simply a story about machines replacing humanity. It is about fundamentally changing the kinds of work we do and the ambition of the problems we collectively choose to solve.
So, to wrap up this explainer, I want to leave you with this. The robot revolution isn't coming someday in a distant science fiction future. It is already here. It is quietly but fundamentally reshaping our global economy, redesigning our workplaces, and restructuring the very foundations of human civilization right under our feet. The world is permanently changing, and now you understand exactly why and how. So the only question left for us to ask is, are you ready for the new reality?
Thanks for watching World Decoded. Make sure to like and share, subscribe, and stay curious.